Hello, in this particular talk we're going to have a look at AI controlled agents we might have within our games. When we think about an AI agent, it is just that. It's an agent, an autonomous entity within the game that is able to take some action, to ponder things, to think about things itself, and sort of embodies, if you like, an entity within our game that can act independently and on its own. Agents, AI-controlled ones, don't simply apply to games. They're quite a broadly used element within artificial intelligence in the wider sense. There's a nice definition here of an AI-controlled agent. So an autonomous agent is a system, so a piece of software, situated within and part of an environment that senses that environment. So in this sense, it's a piece of software that lives notionally or exists within some other environment, quite often another software environment. And the agent is able to sense, to make sense of, to detect, to recognize things. Other than that, and acts on it over time in pursuit of its own agenda, and so as to affect what it senses in the future. So in other words, it's a piece of software that is able to receive inputs about the environment within which it exists, and then based on those inputs to take some particular course of action in pursuit of its own agenda. So here we're saying that an AI-controlled entity has an agenda. It has something that it is trying to accomplish, and it acts towards those particular goals. So I mean, this is generically defined, and you can have agents that sit in networks that try to sort of detect suspicious behaviour, or other ones, any sort of real purpose by way of an autonomous piece of software. In terms of games, when we're thinking about AI agents within a game, generally it falls into ones that we could characterise as an opponent. That would be most of the cases against the player. It could be an ally to the player, it could be a neutral character, but it's some entity within it. For all of our AI-controlled agents, they have a common sequence through which they iterate. So if you like, you imagine this as part of their update phase. So within this, they will go through a phase of sensing. What do they detect or know about their environment? Followed by a phase of thinking, based on what they have sensed in their environment. What does that entail? What does that mean in relation to them trying to achieve their particular goals? Thinking is then followed by an acting phase, which then determines what it is that agent is going to do, what action is it going to take. There can be, depending upon the agent, some steps beyond that. Basically, it comes into learning behaviour or adaptive behaviour, where you're getting the agent to evaluate the success of its particular actions in terms of achieving its goal, and remembering things that have worked, trying to make sure it avoids things that haven't worked. And there's an awful lot of potential interesting complexity within this. The first component, if you like, of this sequence is the notion of sensing, of enabling our AI-controlled entity to sense about the world. And the ones that we're writing within a game, now if you wanted to, you could give your agent perfect information about the game world within which it lives, because you're the programmer. So I mean, it could know the precise location of the player, all of the stats of the player, precise location of everything else, where all of the different objects are. Generally, the player, though, would find or would feel that's unfair. It's an unfair advantage for the AI-controlled entity. So very often here we are actually putting in a sensing model so that we have rules and conditions that determine what an AI agent is able to be aware of, and then hence make its decision making on. So first one we're going to look at here is trying to simulate, it is only simulation, of sight within a game, that an AI agent is able to see other objects and then take action based on them. So we're going to use a simple sensing model here, and we'll have a look at some of the steps. So for each game object, now we're assuming we're the green circle, and the red circles are the other entities that the AI-controlled agent could potentially sense, and they may be stored in an array, so if we want we could give it perfect knowledge, but we're going to introduce a sensing model. So for each game object, one of the things we could do is to put in a viewing distance. So we say that this entity is only able to detect other agents within a certain distance of itself. And that will include and exclude some of the objects that we have within our world. We might also say that the agent, certainly if it's like a character or a person, something that has eyes, that it has a particular viewing cone or direction that it's facing, and a viewing cone within or without that direction that is able to detect characters within. So there, something that is behind it wouldn't be sensed in terms of the model of sight that we're developing here. So we can put this in. We can test where each of the different objects are in relation to this game object and exclude those that it can't see. Finally, we could also put in some tests based on the types of objects and other things we have within our game world, so sort of line of sight tests. And again, putting that in, it gives us a way of further restricting so that we can more accurately determine what other objects this agent is able to see. Now, all of this requires work, all of it requires effort, that's fair enough, but it does give us a more accurate model of an AI-controlled entity that's meant to simulate something like a person or some entity with eyes in our game world. Sound is another common sense, certainly when thinking about ourselves, and again, we can model how an AI-controlled agent is able to detect sound. Generally, it tends to be a fairly simple model that's used, and quite often a sort of an event-based model. So if there is an action taken by another entity or by the player, for example, movement, then this notionally, for example, generates a sound event, and that will trigger any agents that are listening for that particular sound event. Very often it's simply done on a distance, range-based setup, that within a certain range, an AI control character will hear that sound, and generally they sort of have, the first time they hear it, they go into sort of a curious mode, second time maybe alert, third time alarm or whatever. You can vary it, so the type of surface the player's moving over, or the other character, the speed with which they're moving, all of these things can determine the radius within which other AI agents can hear this sound and how they should react to it. One other aspect about sensing is the notion of reacting to something. If we're running our game at, say, 50 frames a second, and we have a sensing model where we're looking to see, well, do we see the player? And we do see the player. If we want, we could take action then and there, more or less immediately. And that would, we can do it, but it wouldn't look particularly accurate or fair to the player, that as soon as the AI character sees the player, it is instantaneous, or they would perceive it to be instantaneous reaction to them. So again, if we're trying to simulate human-like entities within our games, very often if we detect something, we'll put in a small delay before then the AI entity will begin to take an action, or thinking about the action it's going to do in reaction to that. So for vision, it could be maybe say up to half a second, similar for maybe for sound. If we have characters talking to other characters and alerting them, we've sort of got to wait for their audio to finish, and then again maybe have a small delay beyond that. And all of this is actually about putting in limitations, but limitations that we, if you like, are subject to. After we've done our sensing, so we've detected whatever it is we can know about the world, the next phase is thinking. And this is where we're going to process this information and to say, well, what is the significance of what it is we can sense? There's two broad approaches that are used towards thinking, and we're going to have a look at quite a few of these. One of the broad approaches is basically to use expert knowledge. So this is where either the programmer or some other third-party expert says that, okay, in this situation, given this knowledge, here's what I would do. And you can encode that particular information in terms of rules, in terms of conditions, or whatnot. The other common set of approaches is to have an algorithm that tries to process, to parse, to reason about the information that you have sensed, and then to make a decision based on that. So it's more of an algorithmic approach. Lots of different approaches. In hand-waving sense, you can broadly say or summarize it. For expert knowledge, it's reasonably easy to collect, reasonably easy to include within the behavior of the agent, but it can be of high quality, but it maybe has difficulty in terms of adapting to different or new or novel situations. For the algorithmic techniques, they can adapt to new or unseen situations most often, because it's an algorithm, some sort of process, but there may be more of an issue there in terms of the quality of the reasoning that it engages in. So it is swings and roundabouts in terms of advantages and disadvantages for these different techniques. Sometimes, if we're thinking about the processing the agent doing, sometimes we actually have to make the agent less capable. And it comes down to, for example, shooting towards the player or aiming at the player. If we want, we could calculate these things precisely in terms of how to direct something towards the player. So there are a number of different types of action that in terms of a computational algorithmic process, we can do to a very high level of ability. But to make the game interesting and challenging and fun, again, our AI entities we're doing here, they're not to do it to the best of their ability. They're to provide an entertaining and engaging experience for the player. So sometimes we need to dumb them down, or to get them to do things that maybe are a little bit silly, just to give, moving out of cover, just to give some opportunity to the player. Conversely, other times we might need to let agents cheat. And it depends on the game, can be different reasons for doing this here. Sometimes for the higher difficulty levels, you would actually put in give them an unfair advantage. And you sort of flag this up to the player, now, sort of normal or hard or impossible or whatever, so the player knows that, yes, okay, and these other ones, they're playing with a distinct disadvantage to try to let the AI-controlled entity have a chance against them. Sometimes for computational reasons, it would take too much computational effort, for example, to have a very sophisticated sensing model. So you cheat a bit and you sort of remove some of the knowledge, because it gives you roughly the same outcome, but at a much lower computational cost, or for development time reasons as well. Once we've sensed, once we've thought about what that actions actually mean, the last thing we have to do then is to act upon the information that we've been able to sense and to reason about. Depending upon the entity, it'll have a range of actions that it can potentially put into play, and we're trying to pick an action that, through our reasoning, that enables us to best achieve whatever goals or objectives this AI agent has. So actions, you can see a list of them there on the screen. It really just depends on the game and the type of character that is being operated. Acting, other than taking individual actions, so for example I could move my location, I could play a particular animation, or acting may also be interacting with other objects within it in terms of sending them messages. But again, just depends upon the nature of the game. So in terms of key takeaways from this, it's fairly simple. If we're thinking about an AI-controlled agent, most easy thing is to break it up into 3 stages in terms of what it is we sense or can sense about the world, a thinking process that enables us to determine, okay, how are we going to try to best fulfill whatever objectives we've given ourselves, and then an acting process where we put into play one of the actions that we can do to help us try to realize our particular goal. And if you take your AI-controlled entities and separate out their behavior using these 3 different categories, this will give you quite a capable way, or a good way of breaking down their functionality, making it a little bit more manageable, but also making sure that we're differentiating the key components that AI agents do.